Hey data detectives, welcome back to the channel where boring spreadsheets come to life. Ever stared at rows and columns thinking, is this a data report or a secret code from Matrix? Well, you are not alone, and today's video is going to change that all. We are diving into the magical world of data visualization using our trusty employee dataset. Think of it like turning numbers into pictures, but cooler and way more insightful. We'll start from the ground up, that is univariate, bivariate and multivariate visualizations, all explained in a super fun and simple way. So grab your chai or whatever fuels your data brain and let's turn those plain numbers into something spectacular. So alright, let's get into the heart of it. What is data visualization? And why is it such a big deal in the world of data science? So we'll think of data as a treasure chest, full of insights, patterns and stories. But there's one problem. It's locked. Data visualization is the key that opens it. It's the art, science of turning raw data into meaningful visualizations, like charts, graphs, and plots that help us to see what's going on instead of reading 10 pages of numbers. You get the story in one single glance. So in data science, we deal with a huge amount of data. And trust me, no one has time to stare at 1,000 rows in Excel. So here's why data visualization is non-negotiable. So to understand the data, it helps us spot trends, patterns and outliers quickly. Next is to communicate clearly. Whether you are explaining your findings to a client, your boss or your YouTube fam, visuals speak louder than numbers. And to make better decisions also. Visuals helps decision makers take action fast based on the real insights. It's like this. If data is the ingredient, then visualization is the recipe that turns it into something more delicious. Now in this video, we are going to master the three major types of visualization. Univariate visualization. This is when we explore just one variable. How many employees are from each department? We'll use bar charts, histogram, pie charts and more. So let's get started. But before getting started, we need to load our libraries, to load the data set. And one thing is there that we have to we have to create one different column from an existing column. So let's see how we are going to do that. I'll start by importing the libraries and dataset, okay? Okay, so here I have imported our libraries, like we need pandas for this, and as we are going to work with the visualization, so we need Matplotlib for it. I have used allies for each and every library, like PD is there, PLT is there, SNS is there, okay. From Seaborn, we are going to get visualizations like we have histplot and boxplot and all those things. Those we can take from Seaborn library. From MPL toolkits, we have this mplot 3D. From that, we have imported Access 3D. Access 3D, why we are going to need this? Because we are going to make one visualizations that is 3-dimensional. So that is why we have imported this. Then I have my dataset, employee dataset is there, employee information file is there, okay. From read CSV, I have given this path to that, means like in my system, this is the location where that file was present. So I have took that, and to view what is there in our data, what I have did is printed first 3 rows of my data, okay. So what we have in this data, we have the first name of the employees, we have the last name of the employees, we have their gender, DOJ means date of joining. In that we can see that we are having a null value, okay. So current date is there, at what time this data set was created, that's current date this is. Okay, designation is there. In designation we have the role of this employee, like analyst is there, associate is there, right? Okay, in age we are also having one null value, and age is in the decimal, like float points, right? So that is not a correct data type, so you have to change the data type also. You're going to do it by yourself, because in the previous videos we have seen how we are going to change a data type. Next we have salary of those employees. Okay, we have unit. In unit it is department, like in finance department that person belongs, in web department that person is belonging. So like different kinds of unit. If you are okay with this unit, you can keep the column name as unit only, or if you are familiar with you can understand things clearly by department, you can change that unit to the department. Okay, next we have leaves used and leaves remaining of those employees. Ratings are there, and the past experience of those employees. Okay, so this is the information we have with us of those employees. Next what I have did is df.info. With this info I am going to get detailed information. Like here only we can see the first 3 rows, right? But now I want the detailed information. Like detailed information means what we have used from pandas. We have used data frame. Okay, data frame, we can see that our data is printed in the data frame only. Okay, then there are in total 2639 entries, and it is being indexed from 0 to 2638. We can understand this thing, right? Means total we have this 2639 rows, but how are they indexed from 0 to 38? This 38. Why one less? Because we have started it from 0. Okay, that is why. Then date columns are there, means like columns are there. There are total 13 columns present with us, like this first name, last name, this. If you want to calculate, you can calculate that. Then these are the column names that we have. They have been indexed from 0, that is until 12. Okay, now why, don't ask me that why they are 13, because it is only showing 12. We have started from 0. Okay, then first name, last name, in that you can see that how many not null values are there, count, and d type. D type means data type. Okay, now you are familiar with these things. What we have, how many types of float data types do we have, means in columns how many types of float data type is present. There are 4 such columns in which we have float kind of data. How many types of integer columns are there? We have 2, and object 7. Object means that is not defined. Okay, the data type is not defined properly. How much memory is being used, that is also shown over here. Now what I'm going to do is I'm going to quickly create one new column. I want the column of year. From date of joining I am going to create one new column in which only year will be present. Okay, from that only dates I am going to just extract year and keep it into new column. Okay, so here what I have did is I have took that date of joining, that column is there. We are having this, you can also see this is the column we have with us. In a data set we have this doj I have took from pandas. I have this to date time, means first I have to convert its data type. Okay, I have to tell that it is the date time column present. It means information present in that column. Okay, so I have converted it first to df.doj, means that I have converted to the date time data type. Okay, and from that date time I am telling that I create a new column, that is this doj year. This new column created, and in that from this date time from this doj just extract year. Okay, just extract year and keep it in this column. So that is why it has created. Now again if you will see, okay, we'll execute this, and if we will columns, so here you can see that we have this doj year also. If you want to see again df.info, you can print again, and here you can see we have this 13 columns present, means in total we have 14 now. Okay, and here if you will see this doj, it is also being converted to date time. Okay, and this doj year, it is float. So within this 2 lines only what we have did, we have converted the data type as well as we have created the new column, and in which we have stored the year. These things now we require. Now you are saying, you must be thinking that within this we are having null values, we might have duplicates also. Okay, but what is the thing over here is we are going to clean this data alongside visualization only. Okay, we are going to create visualizations also, and in that only alongside, side by side, we are going to work with the cleaning part also. You will see how. So now let's start with our univariate visualization. We have did all the requirement things which we wanted. Okay, we have understood our data. Now let's start creating it. So now we are going to plot the histogram. But first, what is a histogram and why we are using it here? So a histogram is a type of bar chart that shows the distribution of a single numerical variable. It tells us how different values occur in a data set. So in this case, the ages of the employees we are going to take. Okay, to see any of the duplicates, we are going to use this histogram in simple words, if we'll say. You can think of it like sorting people into age buckets and counting how many fall into each one. Okay. It's super helpful to see where most of your data is grouped. So now why are we using it over here? Because before we start doing any fancy analysis, we need to understand how our data is spread out. Are employees mostly young, mid-career, older, or are there any outliers? So a histogram gives us a clear picture of that distribution in just one glance. Okay, so now what I have did is from Seaborn library, I have took this histplot. Okay, histplot means histogram. I want for short name for histogram is hist in Seaborn library. Okay, so histplot I have took. In that we are going to work with the age. Okay, so age I have took, and as I told that cleaning part also we are going to do side by side with the visualization only. So I have took this drop null. Drop null means in the age column if there are any of the empty values, it is going to drop here itself only. KDE we know it is kernel density estimation. Okay, it is true means we are going to see a one smooth curve line in our visualization. Okay, and color is going to be sky blue. If you want to change color or if you want to take any other color, you can take it. Okay, then plt.title from Matplotlib, there is one title name function. Okay, you can understand it like there is one man with the plt, he is known as title. So what is his thing is there, whatever the title we are going to tell him that see distribution of employee age, this I want to pass this title to my visualization. So what he is going to do is he is going to take that title and he is going to give that title to that visualization. Okay, then x label is there. Okay, x label means as we are plotting, so we are going to have x axis, y axis also. So to that x axis we are telling that this age column you will take the responsibility of this age column, means like whatever is there you are going to show it. Okay, this age you are going to print it on that x axis, and y label is going to print frequency. plt.show, what it is going to do is it is for all these things, the title, x label, y label and all these things, it is going to show the final output by combining all those things. Okay, so let's execute this. Here is our distribution of employee age. This title, it has been printed over it. This frequency, x label, y label, all those things are there. In x label we passed age. This KD means our kernel density estimation. This line curve is there. By looking at this curve also, like where it is peaked and where it is low, we can understand by that also. Okay, means like we can see that 25th age of persons are most, okay, they are higher in that organization, like that we can see over here. And with that, by looking at this chart only, we can understand the things. plt.show, what it has done, it has made this visualization that we can observe now. Okay, color sky blue is there. You can see the color of the bars. If you will not pass this color, then also it is okay. It is also going to execute still. Then also copy this and then delete it for a time and then execute. You can see the color is still there. Okay, means I think default color is also there. This is the default color only. Let's think that if I'll execute, I think blue color should have come. Okay, default color is also I think blue only. That is why if you change this color to pink, now let's see. Oops, we have passed this 2 times. Okay, see, you can see the color is being changed. So that is only the thing that this color is doing. Okay, default color, if we didn't pass, then it is blue. So whatever color you want, you can give it. Okay, So this is a visualization we have created. This is a histogram. Okay, you can understand by looking at it only what are the things. So now what this plot is telling us, we can instantly see which age ranges are most common among employees, and it is also telling us that if the ages are evenly spread or clustered around a specific range, right? Combined with the KDE curve, it gives us a clear story of our employee age distribution. That is also the thing, right? So if you want to take any of the real world example, so let's see what we can take. Okay, if you were working in HR or planning training programs, okay, this chart would help you tailor initiative based on employee ages group, right? So now let's focus on our next visualization, that is going to be box plot. So why are we going to use box plot over here? A box plot, also known as box and whisker plot, is a fantastic tool for summarizing how your data is spread out and spotting any outliers. It shows 5 key summary points. Those are minimum, first quartile, medium, third quartile, maximum. And if any data points are way higher or lower than the rest, they are shown up as outliers. So why are we using this box plot over here? Because we are analyzing employee salary, and let's be honest, salaries can vary a lot. Some might earn average pay while a few might be making way more. And if we want to see that clearly, then let's understand this box plot. So now let's check this code, okay? So here from Seaborn we have took the box plot, okay? In that Seaborn, it is box plots requirements are like it have y-axis, okay? One of the axis we have to pass the value for that. Now as we are checking the salary, so that is why from our data set we have passed that salary column. Color we have given light green, okay? Whichever color you want you can give, okay? Now you have seen how we are going to use this color. Then title, y label and show, those things are familiar with us, right? So simple, we have took this, we have passed a column, okay? Here we have did nothing cleaning is there, that in the salary is required, okay? Now if there are any salaries that is way more higher, then we are going to check in this outliers only, right? So right now we are not going to remove any of those things, okay? When we will see in this box plot, then you will understand the thing. So here this is the box plot, okay? Let's understand this a bit. Now in the y-axis we have passed the salaries, okay? We have given this name, salary distribution is there, and this is our box plot. Now here we have this for this minimum, first quartile, medium, third quartile and maximum, right? These things are present. So this, whatever is lying between this line and this is okay, that is fine, okay? Right now we cannot zoom this figure, that is why I'm not able to show it in detail. But now I'll tell you, anything that is lying from this line, means like this middle line you can see over here, from that middle line to this, means like this small line, anything lying between that is known as first quartile. This middle line is known as median, okay? And this line is known as third quartile, okay? Means 75% of the data. So this is the thing that this interquartile range and all those things have been showing, okay? So box plot is good for this. And anything that is lying outside this line you can see over here, anything lying that is outside this line are being considered as outliers, okay? But it is not the case that all the time they are outliers only. There might be the cases like we cannot judge a book by its cover, right? So what happens is, if anything that is out of the range, means in given criteria, if then anything that is out of the range, we are telling that okay, this is not a required thing. The outside things are not the required things, or they are outliers, like that we will consider. But not most of the time they are outliers only. There might be some of the factors that within that they are not fitting. Everything at its place is good, okay? So we cannot consider everyone as outlier only. So now this gives us an overview of the entire salary distribution, right? And we might see, so those dots, those are whiskers, okay? They are also being flagged as outliers, but it is not all the time that they are outliers only. When we group the salaries by department or unit, those so-called outliers might actually be normal salaries within that group. It's like calling a manager's salary an outlier just because we didn't compare it with other managers, right? Okay, so what do? Simple. We break it down with subplots. Now I'll create subplots and I'll show, then I'll explain it, okay? So you can see I have written this code, and then we are, by each department, unit, okay, department thing was in a unit, right? Unit column was there. So by each unit I have separated everyone's salary. So in there also there may be experience, so we can take the experience column also. But here, as we are learning with the univariate thing, but now as we have passed two different columns, so this is not univariate now, it is multivariate, okay. But for understanding this is important. So this units and num units, what we have done here, we first grab all the unique values from the unit, okay, which tells us all the departments or teams. We also calculate how many units we have, because we'll need this to decide how many subplots to create. Then next what we did is fig axis, this axis, right, these things we did. So now what these are, I'll explain this. We use plt.subplots to create grid of plots. We are arranging the plots in 3 columns and the number of rows is calculated to fit all the units. The +2 ensures that there is room even if the numbers isn't a perfect multiple of 3. We then flatten the axis into a one-dimensional list, so we can loop through it easily. For next, this for I in unit, like these all things, now that I'll explain, okay. We now loop over each unit. Inside the loop, we filter the data frame to only include rows from that specific unit. Then we use sns.boxplot to plot the salaries of that unit, and then each subplot gets a custom title like salary in sales or salary in IT, and then we label the y-axis as salary for clarity. Then what we have did is, sometimes we create more subplots slots than needed, like if we had a need of 7 units but made a grid for 9. This loop deletes those extra empty plots to keep the final figure clean and professional. And what's this tight layout? This prevents the plots from overlapping each other. It adds nice padding between subplots. Finally, plt.show, we know now what this does, okay. It displays the 4 beautiful dashboards of salary box plots by unit. So why we did this? By plotting the individual box plots per unit, we were adding context to the salary data. What looks like an outliers in the overall salary box plot and may actually be normal within that unit, right? So that is why we did this. So this is a perfect example of how multivariate visualization tells us a deeper story. So let's say you have an employee data set and you want to find out which unit or department has the most employees. That's where Seaborn's count plot comes in. So now let's learn about this count plot. So now let's understand this count plot, okay. From Seaborn library we have took this count plot. Here we have x, so we have passed the unit to that x. Then we have created one variable named data, and in that we have stored a df, okay. Df means a data only. Then palette is there. Palette why we have took, because this color you can see. If you remove this palette, what is going to happen? Let's see. See, the default color is given to all of the things. So that is why to make it clear, to make it visually look appealing, that is why we have took this palette. Okay. But whenever we are using palette, we need a hue with it. Hue is what, when we want to pass any third column to it, then we are going to use this hue. Then next what is there? Title is there. Title what we have given, number of employees in each unit. Xticks is there. Xticks and rotation 45 we have added. Okay. Here you can see that this finance, web, IT, they are slightly bent. Means like 45 degree they have been bent. Okay. If we make it as 90, we have learned in a school also, right? Then it will look as, oops, close, executed. You can see now they are fully bent. So that is only the thing that is x6 is doing, and then plt.show we know. Here also what is the error it is telling us, that count plot x unit data and palette is equals to this, whatever it is. So palette we have assigned, but we have not assigned hue to it. That is why it is telling us that we cannot use palette, but palette should be used with hue only. That is the thing it is telling us, okay. And here is a plot. This shows us how many employees are in each unit. You can instantly see which departments have the most or least number of employees. You have no need to scroll to the rows and rows of the data, right? Count plots are amazing for visualizing categorical variables. They help us to see patterns at a glance, which is super helpful in EDA. Now let's start with the bivariate visualizations. Okay, so here's our data set. It includes employees' details like their age and salary, right? Which is perfect for a scatter plot. So let's go plot the scatter plot and then I'll explain it. So here we have plotted a scatter plot. Simple things are there, like scatter plot is there in Seaborn library. Okay, we have took that, we have passed age to it, we have passed salary to it. Okay, now two different columns we have passed. That is only thing in this bivariate visualization. Data we have, df means our data is stored in data variable. Okay, and color we have passed, that is red color. Okay, you can pass any other color whichever you want. plt.title, x label, y label, those things are okay. But new thing what is here, that is grid. Okay, grid we have passed true. Let's see if we make it false, then what it is going to happen. If we make grid false, then you can see that those lines were there, boxes were there, those are being removed. That is only the thing that this grid is. Okay, now let's make this. So with these grids we can understand our data more clearly. That is why we can understand the actual points that within which range which those dots are being lying, that we can understand. Each dot on this plot represents one employee. The horizontal position shows their age and the vertical position shows their salary. Okay, now let's analyze this. Wherever there is dense area, just focus on that. Okay, if the dots are moving upward as age increases, that means that older employees tends to earn more. But if the dots are scattered all over with no clear pattern, there might not be a strong relationship between age and salary. If you want to take any of the real life example to understand this, then let's say that you are working in a company and you notice that most freshers in their 20s earn around 25 to 35k. But people in their 40s or 50s might be earning 70 or even a lakh, right? A scatter plot will help you to visualize this trend. But here's a twist. Sometimes young techies with niche skills earn high salaries too. That's why scatter plots are greater for revealing exceptions and outliers. Now let's imagine we are working with a company employees data and we want to check if their salary is difference between male and female employees. Instead of reading rows and rows of numbers, we can visualize it using box plot. But now we are again plotting box plot. Okay, but we are using with bivariate visualizations, and there is going to be a twist also. So just wait for that. So here you can see that again I have used palette. Okay, so that is why it is telling me that you should use hue. That is only this error is telling. Okay, this red highlighted thing is telling. Rather than that, you can just focus on here. Box plot, we know from C-bound we have took box plot. Here we have passed two different variables. Okay, and data is there. Now let's use hue also here. Hue. Okay, now you can see this thing. From we have passed X, Y, and this hue we have given. How to give this hue? In that we can pass any third variable which we want. Third column I have passed which I want to view. Okay, based on that I want to view this. That is why data palette. Now you are familiar with this title also, you are familiar, and this also familiar. Now we know how to read this box plot also. Female, this is there, male counts are different. Female and male by gender we have segregated the things. Their salaries we have segregated. Okay, there are many outliers present, but they actually in actual they might not be outliers. Okay, finance is being defined by green color, web is being defined by orange color, so that is only this hue thing present over here. If you are familiar with Power BI, then you can if you know the tooltips, then you can understand the things. So this is a simple box plot. For right now I'm not going to use this hue because I want to explain the things in this way only. Okay, the box shows the middle 50% of the data from the 25th percentile to the 75th percentile. Okay, these box these things, these known as, these are showing the 25th and 50th and 75th percent of the data. Okay, the line inside the box is the median, the middle salary of those employees. Okay, the male, this middle salary, this line is known as middle salary. Okay, that is the median. The whiskers extends to show the range of the data except outliers. Okay, these are known as whiskers and they are showing us the extent, range, and those little dot outside the whiskers, those are outliers, usually high or low salaries. The whiskers extends to show the range of the data except outliers. This area is known as whiskers. Okay, with anything that is lying in this range, that is known as that is okay, those are not outliers, and anything that is lying outside to that is known as outliers. By comparing the two boxes side by side, you can immediately spot the differences. Is the median salary for males higher than for females? Now answer these questions, okay, in comments. Is one group's salary range wider, or are there any more outliers in one gender? So you can tell me these things in the comments. If you want to take any of the real life example, then what we can take is, for example, if the female box is lower and tighter, it might mean most female employees earn similar, possibly lower salaries. And if the male box is higher and has more outliers, it might show higher variation, possibly more people in the high paying roles. Okay. So of course, just seeing a difference doesn't automatically mean discrimination, but it's a starting point for deeper analysis. So now why these box plots are powerful? Box plots are super powerful because they tell a whole story in just one glance. What's the typical value? How spread out a data is, and there are any extreme cases. So like those things, box plots help us. Now I'll ask you a question, okay? How have salaries changed for employees who joined in different years? To answer that, we can use a line plot. So here is a line plot. From C1 we have took line plot, okay? We have assigned, now as we are time over trend is we are going to show in this. That is why for that cases mostly line chart is only used, okay? So line plot we took, for in that line plot it is having x axis, y axis, okay? We can pass hue also because we have passed a color. So those things are there, okay? Data is equals to dir ci. What new thing over here is the ci is none, that I'll tell, okay? Color, purple, title, x label, y label is there, and then show is there, and here is our line plot, okay? So what is there in our we created this new column, right? Year of joining. So in 2013, in 2014, like that it is showing that in these years not most employees have been hired, like that. And their salary ranges, okay? So like that, these things are present over here. The CIN, what it does is, we are telling Seaborn not to draw confidence intervals, to keep the plot clean and focused. Okay, if we remove this CIN, now this is the single line, okay? We don't want confidence intervals here itself. So that will not show our data more clearly. So that is why just copy this and then remove this, because we are going to add it again, okay? Now see what this confidence intervals are. So we don't want, it is actually be not giving us a proper fixed that exact number which we want, right? So that is why we did that CIN. We want the clear picture, so that is why we just made this line. This plot shows the average salary for employees who joined in each year. The line connects those average salary values across the years, giving us a clear view of trends over time. Now, if you notice a sharp increase around 2018, so if you want to take any of the real world example of line plot, what we can do is, there are HR analytics, business strategy, financial forecasting, even marketing performance tracking is also there, okay? In these cases, this visualization can be used. Now let's move on to the next visualization thing, that is multivariate visualization. Now, as the name itself is only telling us that what this multivariate visualization is. First, in univariate visualization, what we were doing is we were just passing one column, okay? And in bivariate visualization, we were passing two columns, okay? Two columns, two variables, whatever you can think. By two things, we are comparing in one chart, okay? Now here in this multivariate visualization, we are going to take multiple factors, and based on that multiple factors, we are going to compare the things, okay? Now here, by looking at this example, you can see that selected calls. I have created one variable, and in that I have passed multiple factors. Multiple factors means multiple columns over here, okay? Age, salary, past experience, and ratings I have passed, okay? From that, then I have took this pair plot. Pair plot, what it is going to do, by the name on itself only, we are going to understand that it is pairing some of the things, okay? So this pair plot we have took, and we have passed the selected columns, means these 4 columns in that pair plot, okay? Then we are going to drop any null values within these columns if any of them are present, okay? And then we have what we want diagonal kind of KDE. KDE means we know, and corners true, that I'll tell. Okay, subplots, like there are going to be different numbers of plots. Okay, so you can see this there are many plots over here. Okay, so this subtitle is there, means subtitle means to each plot individual name we want to give, so that is why. Okay, so what it is going to be subtitle of that, that is age, salary and all those things is there. Okay, this why 1.02 I'll tell that, and this show. Now hold on, let me explain this down before your brain yells 404. Understanding not found. So the selected calls I've took because we picked the cool kids from the data frame. Okay, means like age, salary, these are our cool kids. Okay. Drop null, it is going to, because nobody wants empty values, right? So we are going to drop any of the empty values present in this. Diagonal kind of KD means smooth curve on the diagonal instead of boring histograms. You can see this curves here. Then corner is equals to true means because we don't want to be too repetitive, right? One triangle is enough, so that is why we have took this corner is equals to true. And let's say your scatter plot says as age increases, so does salary. That's right, experience does pay off unless you are an influencer. So my dear data ninjas, the pair plot is your best buddy when you want to check relationships between multiple variables fast. You want to spot trends, clusters or outliers. You are building a machine learning model and need to see what's related. So in those cases, this plot is very useful to us. You can see. Yes, we are turning the heat up and throwing in some color drama too. Now let's start with the heat map. Okay, I'll quickly write the thing and then I'll explain. Why this heat map we have took? Because every data set has secrets, and this plot, it's basically the neighborhood gossip auntie. It tells you who's close to who. Now alright, line by line, what is happening over here? Let's start. Okay, before here we have created the selected calls. Okay, now here what we are going to do is we are going to use that thing only over here. So ds selected calls dot core means that is this thing. Okay, I'll tell this calculates correlation coefficients for all numeric features. And not true, what it is doing is, because we want the juicy details, not just colors. That is why. CMAP, cool warm, fancy way to say, blue means chill, means like negative, red means things are heating up, positive. Okay. Line width is equals to 0.5, that is separates cell with some neat, clean grid lines. Classy stuff, right? So here now, as we are learning this correlation thing, in the previous videos we have understood that what is correlation. Okay, in correlation we have ranges from like 0, -1 to -1, 0 and 1. This is the range of correlation. Okay, so correlation values goes from -1 to +1, right? So +1 means best friends forever, -1 means they are sworn enemies, and 0 means like they don't even know that each other exist. Now let's say you see age and salary equals to 0.82. Okay, so it is strong positive, and if salary and ratings are like -0.3, then someone's getting paid but still gets roasted in the reviews. Now let's understand 3D plot. Okay, now normally we do 2D scatter plots, but with the 3 numeric variables, how do you show all of them together without making it look like spaghetti? Simple. We take it to the 3rd dimension, and don't worry, you don't need 3D glasses for this one. So now I'll explain this code. Okay, figure plt.figure fixed size 8.6. Okay, first line, we are creating the canvas of destiny, big enough to fit our 3D masterpiece. Okay, it's like whatever the area is required, we have mentioned that. We have mentioned the size for our plot. Okay, 8/6, that is thing. Then AX second line, what it is? This line tells us Matplotlib. Yo, we need that 3D source. The second line, it is telling that Matplotlib that we need the 3D plot from your XYZ, what these are? We are assigning age to X, experience to Y, and salary to Z. Basically building the XYZ Avengers squad. And then scatter and all those things. The purple dots are where your data lives. Each dot equals to one person's story. And why we have choose purple? Because it's represents royalty. Okay. Alpha 0.4, 0.6, whatever we can take. Okay. Transparency. This is because data should be open and honest, and rest of the things you are now familiar with. Okay, so this blue color, purple, and one circle is representing one person's information. Okay, we have known all those things, and this thing is there all over. Salary is there, past experience is there, age is there. Okay, let's increase this alpha size, and you can see. Okay, I'll make that 0.6. You can see the circles are being a bit dense. Okay, so when they were 4, it was a bit good. I'll keep this only. It is not looking that good, but okay, we can understand, right? The good part over here is like whenever you want to now, okay, you want to make a presentation of this. Now you want to keep this figure into one PPT. What you can do is you can just drag this and then drop it over there. That is also a thing you can do. And then rest of the detailed description you can write side by side to it, right? This is also the thing that we are going to do. So making presentation also, it helps us. So ta-da! There is a galaxy of data points. Look how salary changes with age and experience. You can rotate this baby and view it from different angles like you are inspecting a diamond. See those clusters? They might show you where the experienced people are earning more, or maybe some young prodigies make it big. So why we use this 3D scatter plots? They are perfect for exploring relationship between three variables, great for finding clusters, outliers, or patterns that 2D plots just can't catch. And honestly, they just look awesome. Want to make it even cooler? You can add color coding based on the fourth variable like education level, department, or hair color if you are into that. So that's your quick dive into the world of 3D scatter plots. And boom, there you have it all. A full roller coaster ride through the land of univariate, bivariate, and multivariate visualizations. Remember, data isn't just about throwing spaghetti on a chart and calling it insight. It's about telling stories, spying patterns like Sherlock Holmes. Drop a comment below and tell me which chart you liked the most and which one made your brain go confused. And bonus points if you give your favorite chart a superhero name. Smash that like button just like it's spilled coffee on your laptop. Subscribe and hit that bell like you are waking your data from a nap. Because more awesome data content is coming your way with fewer boring lectures and more. Wait, did I just laugh at scatterplot? Until next time, keep plotting, keep questioning, and keep dancing with your data. I am Devishri, your data DJ, signing off.